All right, all right. Hello, hello, and welcome once again to another instance of coding a memory allocator from scratch and C streams. Okay, so today we're going to be working on intrusive data structures. Let me open the blinds. It's a little dark as usual. We'll open the blinds and welcome everybody. No, lag. You mean, oh, hi, Penguin Operator. Do you mean lag as in like, oh, no lag, as in there is lag, or oh, no lag, as in there is no lag? I assume the first one, that there is indeed lag. I'm not sure. Oh, wait, no, you said lag before, and then you said, oh, no lag. Okay, perfect, perfect. Yeah, yeah, while the stream starts, the CPU, it's like, um, the CPU gets crazy, and then when I open VS Code, it like bam, it crashes, it plummets down, and then you wait for a few minutes, and then it goes back up. so, so that's the reason. That's the reason why when I open stream, it's like laggy, and when I open VS Code, it becomes laggy again. So, yeah, I need to fix my hair. My hair is becoming crazy. I gotta get a haircut soon. For now, I just have to use water on it. Um, Yeah. How are you guys today? I hope everybody's fine. Mm, I'm fine. I'm fine too. So yeah, that's it. That's it. Boom. But okay. So if you remember correctly, yesterday we were working on intrusive data structures, trying to make our red black tree an intrusive data structure, right? Um, and so you know what that means. It means welcome to the coding sesh and the coding scene. Ooh, as always, restaurant music so that we can prepare for the cooking session that's ahead. And we're happy today. It's gonna be a very chill stream, not as stressful as the one where that's the ones where we have to like create new tests or something like that. Um, yeah. So that's great. And so I'll show you what I have done so far. So yesterday I told you guys that I was going to sort of continue because we finished the sort of red black well, we didn't finish it, right? But we had the entire idea. All we needed to do is replace a bunch of calls for the right thing, right? And so what ended up happening and what I ended up doing was these guys, all of this file, I'm sure you guys remember we edited yesterday, and if I remember correctly, we completed, right, totally. And now we needed to sort of perform the changes that were necessary. First of all, the fact that these are no longer block pointers, these are node T pointers. Also, the fact that insertion doesn't really become insertion anymore. You have to trust the user that the node has been linked in the correct place if this was, as if this were to be a binary search tree. It's a cool dysfunction, arbitrary insert fix, because it's like you're fixing whatever the insertion did. And yeah, other than that, nothing else changes. Absolutely nothing else. Right? And so in the user side, we have to implement the logic related to finding something. And that's exactly what I did. I just copied and pasted. I copied the function we had here for find, and then I just put it here under the name of arbitrary find, if I remember correctly. Yeah. I just said arbitrary find is just this, which is the exact same thing it was before. It's just that now the find logic needs to be here. And arbitrary insert is basically the same thing that we had for insertions. The indentation, it's like really bad. I hope I can fix this, but for now, really, it doesn't make much difference. So yeah, perfect. And that's kind of it. That's it. So now that we have performed all of these modifications, and you can sort of see how the calls change, right? So arbitrary find now accepts a pointer to the red black tree, thus making it so that, things change around a little. And that's it. So I was just updating all of these things like, oh, this is no longer a heap pointer, this is just a normal pointer, and so on and so on and so on. So I believe this to be the final translation, but there's only one way to know. The way to know is to run the tests and see that they run well. So that's exactly what we're going to do today. We're just going to edit the files for the tests to see whether or not those changes for the red black tree being an intrinsic data structure are efficient or are indeed correct, right? So yeah, that's all. So let's see. We have this arbitrary test file. It has a bunch of tests for the red black tree. And since our data structure was not intrusive, well, it was like coded exactly to fit the way blocks work. We had this create block function that needed to interact with the heap and that needed to do like a bunch of stuff. None of that is needed anymore. And the reason is precisely because, well, right, we don't really deal with blocks anymore. We can, we can sort of deal with, any sort of data structure. So for that reason and for that purpose, we can definitely just erase all of this. Same here. Perfect. We still need a function that allows us to sort of convert the red black tree into a vector. So arbitrary to vec is yet to be implemented or translated. So let me do that right now. Maya Stella, hello, welcome to the stream. And yeah, so what VS Code extensions are you using? What do you mean? Like, I know what you mean, right? But like, there's many extensions that I'm using. If you want to take a look at them, like, it's these, right? C++ extension, better comments, CMake tools, code LDV, the comment divider, the debug tracker, right? Although, yeah, I don't know why this guy is here. The dev containers, which just were installed there. ErrorLens, Excalibur, right? Hex editor, Makefile tools, Material Icon theme, OneDark Pro. These ones are more for remote development that I needed once. Trailing spaces, this is for my school. To display PDFs, in the WSL one, which I had. These are synced with my main PC, so that's why you see some of them that belong to Windows, because I used to have a Windows computer. So yeah, that's all. Let's see. So Z Tsuji, welcome. Yo, was bored and looking for something to watch. This seemed interesting since I made my own a while ago. Little buggy, but it gives the right concepts for the in-heap allocations. Ooh. Wait, that is pretty good. I'm not sure. So one of the policies we've made is we don't want to look at implementations that already exist, so that we don't have to be biased and then we can take all the decisions from scratch. We will actually, like, let me grab this. Let me copy this. Okay. And let me put it. Oh no, I open Firefox. Lag is gonna come. Don't worry. It's gonna be fine. It's gonna last only a few minutes, a few seconds. If Firefox opens, because hello, Firefox, where are you? Firefox. No, no. Okay, okay. It seems like we're back. Okay, that's good. So I'm going to add this one as a bookmark so that we can explore it later. And put it here. Save. There you go. But yeah, perfect. Thank you very much. We will take a look at it once we are like solid on our memory allocator. But yeah, so let me see. I don't know. Hey, is this a good deal? I bought it to part out for cash. 1300 for a PC with a 7900 XTX, 64 gigabytes DDR5, 2 terabytes and 1 terabyte NVMe SSDs. That sounds like incredible, no? I'm not sure about, you guys what you think, but that offer about the almighty, it's like really good. I'm not sure. Once again, I'm not very used to the US prices, but yeah. Which M series chip? It's an M2. As you can see, it's all one file. So so should be easy enough to find what you're after. Yeah. Hell yeah. Javon, welcome. Do you look at repos and read articles or docs to know what to code? No. It is quite the opposite. One of the policies is to start from scratch, and that is we need to know the basics of what we're doing. So in this case, for the memory allocator, I watched like 2 Carnegie Mellon University lectures on what a memory allocator was, just so that we would be familiar with the lingo, right? What does it mean to have, a memory block? What is the heap? What is blah 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 blah? And then after that, we have as policy to not look at any other implementations of a memory allocator, just so that we can actually start from scratch and we can think through the decisions. That's why I was mentioning to Zeke Suji that like because they also made a memory allocator, and so they shared the link here in the chat, which is pretty good. I love that. The thing is, like, because of that, I said, like, okay, just wait until a few more streams once we have this sort of more completed and finished, and then we'll take a look at it, just precisely because of that. The guy wanted 2,000 and I offered him 1250 a month ago. He was unable to sell it for another month, so I offered him 1,300. Damn! What? That's like a steal. That's incredible. Okay. Let me fanatical pigtail. AI viewers at streamview.com. Alright, buddy, you're getting a banned. Okay. Oh, you read it as Zoo EG. Ooh, okay. Zoo EG. Zoo EG. Okay, Zuiji. Zuiji. Ooh, you also in uni? Yes, I'm in university. Which semester? So in total it's 4 years. I just completed my 30. Well, before this summer, that is, but in May, I completed my 3rd year. So I'm about to start my 4th year. Jabon, you're saying, gotcha. I'm learning Go for the first time and building a Raft consensus engine. Ooh, and I'm reading the Raft consensus algo paper. Yeah. So if you're implementing Raft, right, like you gotta know what Raft is. So of course, yeah, you gotta read the Raft consensus paper for sure. That's pretty good. That's pretty good. That's excellent. Yep, that's it. Okay. Zuiji. Okay, that's perfect. All right. So yeah, you guys can chat. In the meantime, while people chat or if I ask you guys questions, I simply feel free to respond. And in the meantime, I'm gonna be here coding this. So we have this function. We want to have a red-black tree to vector function. And we also want it to be able to store nodes in some result array. So what this guy is going to do, wait, the signature is the same, right? Arbitrary t, oh no. Perfect. So now what we do is we say, well, result, right, result color, this doesn't have a field color. Okay. So this is basically the same as doing this. Let me see. Let's copy that. MD set and whatever they were referring to. Then we open parentheses, we close, and then comma. I think that's it, no? Compatible pointer types. Oh, okay. Oh, I see. So yeah, this cannot be that. This has to be a node. Node. That should fix it. If the extension is, yeah, okay, perfect. Let me think. Actually, this is a little silly. Why am I doing that? I can just do this. Right? Yeah. Let's just do this. Hello. What's going on? Is the extension going slow again? Because I'm not sure why this error is here. I'm about to enter semester 3, second year. Yo, let's go. Honestly, I didn't code much in first year. I'm still lacking those coding skills. That's okay. It's never, it's never too late to start. What it suggests before you go into the allocating of pages that would likely need threads and conversation is to start with a... No. No, don't tell me, Zuiji. Don't tell me. Don't tell me. But, yeah. Yeah, so we have a red-black tree to vector, and I think it's working now, right? Yeah, I think this is the correct one. And so now when we enter here, right, we need a few things. So this new block thing doesn't work anymore. When we say, oh, is this red-black tree equal to the vector that you're giving me? I'm gonna ask it to give me an array of nodes. So here we're gonna say, well, node t, it's gonna be the vector, and then it has these many. So now we convert the red-black tree to a vector by passing in the root and storing it all in vec3, right? And of course, this has to be an asterisk. Perfect. So now what we do is we say, we grab the vector tree, right? We enter the ith one, and then, ooh, that's a little bit of a problem. Okay, that's fine. So I think we're also gonna have to implement our own arbitrary insert, just like we did here. And arbitrary find, just because that's what, that's what is wanted from us. So let me just copy this and then paste it over here. There you go. Of course, these guys are going to be static, and the same thing occurs to the ones in the other file, right? So we say static, and then static 2. Perfect. So when we need to find something in a red-black tree, suppose, let's make a red-black tree be made out of this one struct, right? This little struct called, what should we call it? Type that this guy into, I'm just gonna call it data. A little bit of Okay, but and then we're gonna store integers inside it, which is gonna be called data, right? And then we store inside it, of course, the node for the variable tree, since this is intrusive. Let me read the chat for a second. So I'm gonna skip your message. I'm so sorry, Zidger. Not saying you have to make the allocator, just where to start. The scope remains small enough for you to identify. Okay. Maya Stella. Looks like you're already starting the same scope I was suggesting. Okay, I see. Pretty good. But yeah, it's okay. So you're gonna have this little type def, and of course the data doesn't go here, it goes here. So we have this struct, which is gonna be a little thing that we want to store in a red black tree. So when we perform the red black tree find, right, what we want to do is not this, but rather, right, we would need to have instead of the current block, we need the information about it. So we need the container of well, not only would we need that, I guess we do want this, right? But we want to baptize it as something else. We want to baptize it as current date, something similar. And so with this said, we pass in the data, and then we try to get the arbitrary node thing. Oh, container of is not, okay. I think I define it in utils.h, if I remember correctly. Yes. Okay. So a value of data star. Oh, of course, we get a pointer to the thing. So perfect. And so here what we do is instead we say, well, current data, then we access the data, just so that we can compare it with the rest. Perfect. So that is a find function. And a very similar modification is going to be performed for the insert function because they're basically the same, right? So we grab the data here. Then we say this guy is going to be current data. Oh, wait, sorry, what? This is just blatantly wrong. This is just incorrect. What? Why did I? Huh? That's incorrect. Like, that's always going to be false. So what is the problem? Yeah, why do we do that? Anyways, what we need to actually do is to go down the tree. So what we end up doing is we say, well, if our node, which I imagine to be this guy, if our node is smaller than the current thing, then we need to go to its left, right? Otherwise, we go to the right. So with this thing, what we need to do is if, and then the same thing, container of node data arbitrary node. So I guess I'm gonna move this here to above here. Thank God we noticed this because this is also in here. So we definitely need to change this. Yeah, what is this? I'm trying to, what? Okay, so let's see. We have this thing, and what we're going to say is node t, right? Actually, no, not node t. We need the data that's being stored, so it would be a ptlt, which is you know, block, which is equal to the container of this guy, right, of node when it comes to the node key structure, and then we need to access what's the name? Yeah, arbitrary node. There you go. Wait, what? Arbitrary node. Struct node T. Oh, sorry, it's not node T. It's the BPCI. No, it's the free block header. Sorry. Sorry, guys. There you go. All right. You read the chat. Bada. Ditch the concept of a tree. I don't. Why would I do that? So I want to continue with our design and sort of the decisions we've made. A tree seems to be fine for now. If we ever realize it doesn't work, I want to be able to discover that, by ourselves, that like we actually measure the performance and we see that the tree doesn't work, right? So I prefer to continue with our current implementation, and discover everything, by ourselves, so that the design is actually what we've been looking at. Yeah. So here we have a roadblock tree insert, right? We're doing complicating the code more than you need. I understand, like, one thing is complicating the code. We want, nonetheless, for it to be performant. And we've decided that a red black tree makes sense to make it be performant. I definitely agree that if we wanted to have a simpler allocator, a tree wouldn't make much sense. But yeah, we just want to try it out. Just want to try it out because it seems, from our intuition, a tree would make this allocator very performant. Then we're gonna measure it, and then if it doesn't work, then we try and look for alternatives. But I'm relatively confident that this is a good, a good approach. But I guess only the numbers can tell, and so we'll eventually see. So yeah. Let's see, if our block is smaller than whoever this guy is, then we're going to actually link them together. And I think that's the... Yes, okay, perfect. Perfect. That makes a lot of sense now. So when we perform the insert, right, we want to have data star and then, our data, which is equal to this. And so now here, what we're going to do is we're going to say if a data's data is smaller than the current data's data, then we're going to insert it here. Otherwise, we insert it here. So perfect. So now we're going to translate some of the stuff that we need. Arbitrary equals vector and all of that. We need to see whether or not, the nodes are the same. So how do we do this? Well, we go into here and we say, if the vector tree at this position, so this is the thing that is returned to us. I guess the best way to do it is to do something like, actual data. Actual data is equal to grab the vector tree and then do a container of that, right? The vector tree, and then I guess you need the address, right? Then the type that you actually want it to be, and then the member, which is, if I remember correctly, arbitrary node. Yes, okay. So now we say that is the actual data. The expected data Okay, so this puts it at a little bit of a complication, I suppose. Maybe not actually. So we say expected data is equal to container of, and then we do vectory I, right, then data, then arbitrary node. Perfect. So now what we do is we say we make sure that the sizes are the same. So actual data, make sure that the sizes are the same. If the colors differ, that's also something we want to flag. So if we see that, vectory at I, it's color, right? They always say VK color, if I remember correctly. No? No. Seems like it's ND color. Yeah. If the node color of this guy is different from the node color of this guy, then we're gonna continue, right? So of course this is gonna be, it pointed to it, and this one's also pointed to it. Perfect. Great. Arbitrary equals vector. Test left rotation. Let me see. Da-da-da-da-da. Quick question. Are your allocations of fixed size internally or dynamic? Just want an idea of how complex the code is. They are, so not sure what you mean. Maybe that might be in ignorance on my side. Maybe you're referring to something specific. So sorry if that's the case. The allocations are dynamic. Like a given block can change sizes. If you ask me for 23 bytes, the allocator will decide, it's going to be this. It's not like it follows powers of 2, right? It could just be a block of size 24, right? Or a block of size 36. And then that block could expand in the future to become 53, right? So yeah, that is how it currently works. Let me know if that's what you're asking, because I may have missed the point completely. Arctic Codes, hi Sharif, how are you? Let's go, Arctic Codes is back into the chat. Welcome, Arctic. I'm fine. What about you? So currently we're working once again on a memory allocator. We basically finished it in the sense that we have correctness, right? We know that the allocator works, or well, we don't know that, but we've tested it multiple times and it works. So we have a high degree of confidence that it works. Yeah, and so the allocator is there, and we are just sort of making some modifications. So the main one we're doing right now is we are converting the red black tree to be reusable by implementing it as an intrusive data structure. Because previously the red black tree was crafted to wrap around, the memory allocator itself. And so you couldn't reuse it for anything. And it was something that was bugging me a lot because, it means that you would need to create a new red black tree if you wanted to store a new data type inside, which we're not going to do, but it just was something I wanted to learn. How is this done, right? Since you don't have generics in C, you don't have like generic containers. How are generic containers implemented? And so now we're changing that. And then we're going to measure the performance of this thing to try and see how, how everything is made, right? So yeah. Yeah. Zuiji is saying, okay, so they are dynamic, yes. I went with fixed size so I could verify an address looks valid by what's in the low of bits. Oh, pretty good. But yeah, so now that we have made the red black tree an intrusive data structure, we're trying to sort of, write the tests, convert them to this new sort of syntax, if you will. And I'm trying to figure out what the new syntax is because, it's not that It's not like that simple. I think it's fine though. So if I return true, right, I go here. So we need to port this test. Once we have ported one test, it means we'll be able to know what to do. So we're creating multiple nodes, and that seems to me like we just create data points. So this would be 5, and 5 is just going to be equal to, 5, I assume. 5, and then the red black tree node is simply the default, right? So if I do this, right, notice that data is a struct, and it holds both data here and an arbitrary node. I want this to be initialized to its default. Is this valid in C? Does it initialize it to all zeros, right? Does it zero out the memory as it does when you do like something like this? Is it the same, or is it going to complain? Because currently the extension is not complaining, which it's a little bit of a hit or miss given that the C extension is not the best in VS Code. I'm going to assume it does. Let me guys, like you guys, let me know if it's not the case and actually it just doesn't work. Yeah, I think I can just mass edit this. I can just copy it here, replace all of these guys with data, move over here, then instead of create block, I erase this, erase this, erase this, erase this, move to the other side, erase, erase, and I do this. Perfect. All right. So, sure. I'm gonna do 20, 50. And so now what we want to do is we want to arbitrary link. We're going to link them all together, and I think that one is fairly simple to translate. It's just that instead of these things, right, we need to pass in their address and the arbitrary node. Sorry, this is of course not, yeah. Perfect. And then the same for these guys, right? So these guys address and then pass in the red black tree node. Perfect. Yay. All right. We return and then we do a bunch of crazy stuff. So we test the left rotation, yes. Then we test the right rotation, and it's going to be more of the same, question mark? So I think this is the correct way, right? We grab the data. We don't have any information about them. We just link them together to perform, to make a red black tree. And then we need to actually test it. We need to test that rotation. So now we do this. What we're going to do is we're going to get a pointer to some sort of node, which is res. We rotate not at 10, but at the red black tree node that 10 possesses. Let's wait for it. Oh, sorry. I meant this. Perfect. And so now we need to have a data structure in which to store the result. We convert this to a vector, and then we compare it with what we expect. So what we expect is it's going to be a couple of nodes and all of that stuff. So it should be, the red black tree should look something like this, right? It should be something like 5 dot red black tree node. I think this is more than enough. Well, a value of type, an entity of type int. Oh, so we can just put in the integers. I'm in. Sure. Although, I think the arbitrary equals vector expects, oh yeah, we're not measuring anything about the red black treeness of this. So we can just go, yeah, we can just go file and then data, 5 dot data, right, 2 dot data, 10.data, 8.data, 6.data, 6.data. There you go. Then 9.data. Finally, 12.data. Perfect. And these guys are just integers. Yay. So when we right rotate, oh, what the hell? Oh, okay. I mean, I guess I have to do that. I'll just, invent a bogus red light tree. This guy is just going to be equal to no. Perfect. So it has a pointer to it. Awesome. And so now what we're going to do is we go here and we assert that everything coincides, right? So the thing that's going to be returned from arbitrary to vec, it's going to be the node, node t pointer. Oh no, never mind. Oh, of course, it's going to populate the result. Right, so it populates this with nodes. And so now in the assert, what we need to do is we need to compare them. So we're going to say, container of this thing with as it respects to data, and it is the arbitrary node member. And so once that's done, we access it. Oh wait, this needs to be a pointer. Then we access it to obtain data. Perfect. Awesome. So that's equal to the expected, and then we return true. Okay, so this is the way the rotations work. Great. So let me put this one on the side. And we're going to try to do the same thing, but with the right rotation. The thing is, we now know how it works. And so we're just going to grab this and we're going to paste it over here. It's just that the call to right rotation and left rotation changes. So instead of calling, oh, here I should have called left rotate. Left rotate. And left rotate leaves you with, oh shoot, I was looking at the wrong thing the whole time. Okay, so this should leave you with 10.data, that's 100, 5.data, 2.data, 8.data, and I think that's all, 6.data, 9.data, and then 12.data. Yes, okay, perfect. Then we compare them both, then we end up with that. I see a message in the chat. Give me 1 second. I'll read it in, the blink of an eye. 10 data, Yes, okay, so both rotations tests are completed. Okay. Please let me know. Make it be allocator, make allo, but the first one I like it to go over there. The information is intact. Yeah, sure. Yeah. Okay, so we're gonna test here the insertion now, right? So what we're going to do is we're going to create a red light tree, which we only do in this way, arbitrary. And then we just need to call this thing, arbitrary insert, and then we're going to insert, we're going to insert something that relates to our struct. So I think we can just insert the struct itself, right? We just insert 150 and then nothing else. And that should be it, right? Oh my god, expected an expression. Is this the extension acting up, or is it us? Oh, it accepts a pointer to the thing. which I'm not very happy about. Brother, why? Why is this happening? I think we're indeed going to need those functions that we had before. So what I mean by that is now that this has changed, right? Whenever we want to insert something into the red black tree, it needs to be a pointer to a node T. That is a little annoying. How many will we need? Okay, let me think. Is there a way to somehow do this? So what I'm saying is arbitrary insert, it accepts, node pointers. The thing is, I don't really, because then we have to create a bunch of variables here at the beginning, which is the same we've been doing. So I guess it's fine. We have 15. So let's do just that. So data 15. Right, and 15 is going to be equal to the same thing we've been doing. 150 comma this. And then we just replicate that. And then we grab all of those values that we've been taking a look at. So 50 is the next one. We insert 50. So that is a 50. After this, it's not only 50, it's 10, 10, 10. Then when we insert, it's going to be 120, so 12. Well, this wouldn't be 10, this would be like 1. 12, so then we put a 120. What else do we do? We insert 1, we insert 12, we insert 13. Then we do 13, 13, then we do 130, 130. Then after that, we insert 170 and then 190, right? 170, 190, and those correspond to 17 and 19. 19. All right, perfect. So we have 19, and then we have 21. So we insert 21, that's going to be the last one. Okay, perfect. 21. Perfect. And so now what we do is instead of passing this, we just pass the pointer to 15's red black tree node. Great. All right. That's perfect. But just in case my example wasn't clear, here's another just of 2A. Yeah, I mean, it would be a normal system, right? Like yeah, good idea. Anyways, so we insert stuff here. Now, the problem is when we need to assert the contents of the red black tree, right? I also think I want clang off for this. Clang, it ruins a lot of the formatting because it gets rid of the white lines, which I hate with all passion. But it's okay. So here we have a assert that these things look the same. So arbitrary vector is going to be, it's going to expect an array of nodes. And so that's exactly what we're going to give to them. We give them a pointer of a red black tree. And then we provide what is it that we need. So over here, I think we can just do something like, I guess this is a really bad way. I don't like this. I don't like this. Why is it? Okay, let me think. Let me think. So the interface now to test the red black tree, it's maybe not the best. I am not completely sure. Maybe this is not the best way to try it out. Yeah, so the reason is arbitrary equals vector, right? It grabs a red black tree. Then you give it the pre-order traversal of what it is that that you want to compare. And it obtains the data just as it would with a normal one, right? And so the problem is that is very cumbersome because it means that we need to allocate objects just so that the thing can access the data and do all sorts of stuff. So I think that maybe instead of doing this, we can just pass something like, we can type def some sort of structure. This is going to take a different shape, of course, right? We're going to call it a node expectation. And all it does is store two fields, the two fields we care about, right? So the first one being something like the color of that, so color, and the second one being the actual data, right? So int data. And so that way we can just simplify things and say the node of expected is just going to be, a node expected array. And then over here, instead of doing that, grabbing expected data, we grab the actual data and then we just grab, expected at I, and then its data field, and expected at I, and then its color field. So that way it's like way simpler for us to do. And now we can just write things more easily. Because over here, what we pass ends up not being an array of this, but an array of, node expectations. And we simply specify the color, right? So here I would say it's a black 15, right? So now it's way easier to specify. So yeah, now we're going to insert into a red black tree. So all of these calls, for example, right? Let me just modify them. We need to pass a pointer to the red black tree instead. And instead of the create block, I think that one we can just modify per case. So this one would be, 5. Let me just do then, this would be 1, I take it that's the code testing your allocator. If so, why not just use a loop? Just define a custom test node, something to pass from the previous test to this one, which can then test based on arbitrary info. From there, you can randomize your tests. Yeah, this is just a very, this is a very basic test for the red black tree, not the allocator. The code for our allocator, at least the tests, are in this file, which actually do the random test. We created a fuzzer for our memory allocator and are doing, a bunch of operations in a loop. So these are just very basic tests for the red black tree. Some sort of like corner cases for it, which is the reason why we include them by hand. Yeah. So yeah, I actually want to have this thing over here. Yeah, let me see. Fambieg, welcome to the chat again. Hell, my CPU is overheating. Oh, dude, what happened? Some of the dev. Only this guy is writing code. Indeed. My fan is broken. Oh no. That's really bad. You can embed the node expectation within the data and fail early if the top level code expectations fail, since the stored data of node expectations for the children would be corrupt anyways. Yeah, as I mentioned, like this is not the test for the memory allocator. This is for the red black tree. So like doing this is completely fine. Just because, you know, the red black tree would only be concerned with the nodes. There's no way it can access the data. So yeah. Let me see. When we insert stuff here, right? We want 5. Yes, 1. We want then this guy to be oh sorry, what was it? 12. 12. For this one, this insert, we want 13, right? 13, and then 17, right? Then 19, 19, 21. Perfect. So now we just grab them all. We grab them all. Plop, 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 and plop. There you go. And we grab the address of the arbitrary node. That's what we pass in. Perfect. Let's go. Okay. Not sure why 5. Well, it should have been 50. It should be fine. Perfect. Okay. And so now we fill out our expectations, which I guess is going to be simple enough because there's not much to worry about. Give me 1 second. I don't know why C-line format is always getting rid of the new lines. It's so it's so annoying. Anyways, CS go back. So this guy, and then this guy, and then here. And then for this one, it's gonna be arbitrary lives here. I would say, you know, new line, new line, new line, new line, and then here. There you go. You see, it's more readable now. Arbitrary vector. Not sure why you did that select format. New line, new line, new line. What the hell? And then this. And then the 5. What? Okay, anyways. So we do that. There you go. So we skip, new line, fix whatever hellish mistake the formatter did. This. We jump, we close parentheses, and then this 6 is in some unholy place. We take it back to normal. Perfect. Finally, we set the red black tree. We do the exact same thing. Then we introduce the new lines that C-line format robbed from us. We do this, we do that, we do that, we do that again. We conquer this, and then we eliminate the white space. There you go. Final one. Oh my. Here, we grab this, we put it here, you know, close the gap again. Oh, sorry. And close the gap. Put these guys here, put this here, put this here, put this here. Then new line, and then with 8, we just do that. Perfect. All right, and so now we need to modify things to actually fit what they should. Instead of this node thingy, we're just going to replace it all with node expectation. Perfect. Then these instances of a red black tree, they need to be passed as pointers rather than normal things. So arbitrary comma. So I guess I'll grab with the parentheses. There you go. Perfect. Then we just do this. Let's just solve all of them. Perfect. And now CS node is a thing that's not like sort of no longer defined. So instead, we're just gonna pass in normal, node expectation objects. And the way we do that is we just do the little brackets and we pass in the value we actually want. Perfect. It's done. So the tests has been ported, and it actually looks way nicer. So, hand coding allocation expectations is not my idea of fun. I just automated all the allocations with RNG. Yeah. Like, so, like, yeah, we did exactly the same, right? We have the allocations automated, right? They're here, right? You feed it a seed to the fuzzer, and then the fuzzer does random allocations. These guys, these are for the red-black tree, which are different. So here we're just testing a data structure. Here we're testing the allocator. If that helps with the difference between the two. But yeah. So over here, I think we're just gonna do basically exactly the same. I think it's the same guys, right? Yeah, so we can just copy them over. We can copy them over and then put them here. I also agree, this is not very fun. It is a little relaxing though, but definitely not that fun. When we insert stuff, I would want you to be, ampersand. And instead of running create block, we can just pass in whatever it is that we need. So this guy, for example, this is 15. 15. This guy is 5. This guy is 1. 1. This guy is 12. This guy is 13. This guy is 17. And then this guy is 19. This guy is 21. Perfect. And so now we move. Oh gosh. Okay. We do this. We pass in a pointer to the red black tree nodes. Great. We need to check exact matches. So this is the test for find. Okay, this is a little annoying too, but it doesn't matter. So now what we do is to check for exact matches, we need the data they're storing. That's fine. So I think I'll just do this. I'll grabbing all the assets, delete them, and then just delete parentheses. That should be it. Yeah. Okay, so now what we want to assert is that whenever we try to find into the red black tree, we obtain something that is, the correct thing. So I'm just gonna say data pointer, to result. It's gonna be the container of whatever happens when we do arbitrary find, right? Then arbitrary and then nums 9. Whenever we find, and this is of course going to be part of the data struct under the field of arbitrary node, right? Of course, has to be a pointer. Great. So now what we do is very simple, because now the only thing we need to assert is that res data is equal to whatever we expect. Perfect. And now here we need to do the exact same thing, but this time for lower bounds. And so basically we do container of whatever arbitrary finds. And actually I think I need to know what the value is that we need to find. So this one's 110. So it would be container of whatever you return to me. I'll provide you which red black tree we're talking about, and you'll have to give me something close to 110. Whatever that thing is, please Let me see its value. And then I'll check that it's equal to 120. Let's see. Perfect. So that is indeed the way. So I think we can just mass edit this by selecting all of these. They're going to be the container of something. Or we want the container of these things. So arbitrary, and then we try and find. And when we try and find, we pass in the pointer. And for these things, we shouldn't really be having the s. We should be having the value. And that should be completely fine. This container of is with respect to the data struct, and the arbitrary node is under the arbitrary node thing. And then we delete this. Sorry, I forgot about grabbing the data member. There you go. So now here we need to assert that, whenever we find something in the red-black tree, that something is not null. Okay. Oh, wait, I think that changes a lot of stuff. Because, let me, so does arbitrary find? Yeah, so it's very important that we keep track of, okay, perfect. We assert that this is the case. Yes, okay, so container of, assert that arbitrary find, in this case, with the red-black tree, and when we try to find something for 140,000 bytes, it's gonna tell us, no, this guy just doesn't exist, right? So we just say no. Perfect, so that's that test. Let me now read the chat. Oh, okay, I was wondering about the color stuff. Yeah. I would think the data would be fine if your allocator is working fine for the nodes. Another tip, let the wrappers pass pointers. The internal heap code should be using indices or offsets. Sure, so we had it by passing, you remove an element of failure from the internal code that then can find pointer checks to wrappers only. Yeah, so previously we had it with offsets. We changed it to pointers. But we considered it's very likely that we'll want it to be offsets. So the offsets again. And for that reason, we already have that, in mind, because there is a general type called the block pointer. So a block pointer just refers to whatever you consider to be a pointer. We can just change this to be a UN6040 at any point in time, and then, it's going to work. But yeah, we try and do the test remove. So, yeah. And in fact, I mean, what you mentioned about the wrappers only, it still applies with pointers, right? Like, there is nothing that special about the indices, because you can just check whether or not the pointer falls within the heap, just like right here. Right, so just check that the block is inside, and this is inside the wrappers. So the same principles still apply. Fortunately, right? if not, then it would definitely be a trade-off worthy of following. But yeah. We're gonna grab the same thing once again, because we need to perform the last test. No, this is the second to last test. This is remove. So we perform the insertions of all of them, which indeed I think we did before. So now we do that. And now we're going to have to test what the tree looks like, which is really annoying. We try and remove this. We try and remove. So from 15, 19, 13, 1, 17, 12, 5, and 21, we want to grab the pointer to the red-black tree nodes. Perfect. Then over here, these arbitrary with parentheses, these guys need to be pointers, actually. to the red black trees they're talking about. And now we verify the shape of the tree. So once again, I think it's gonna be great if we turn clang off for this one, because you can see how bad the formatting became after we ran the formatter. So clang format off, sorry, on after this. Perfect. And so now what we do is we try and assert that the red black tree looks like this. We try and get the node experience from here. Then we move this, remove this. We put things here. Then we put things here, put things here. We new line, and then we merge. Perfect. We perform the same modification, which, by the way, I think I missed this guy. Perfect. So now we beautify this one too. So there's only be 6 more. So this is the first one. Da 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 da. With this little curly brace. Da 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 da. There you go. Now the next one, number 5. Do this, 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 and this, and this, and this, and this guy after. Perfect. And now, grab this red black tree. We, new line, new line, new line, new line, jump. Perfect. Only 3 more. And each gets shorter, so that's good. There you go. This one. Bam, bam, bam. There you go. And then we do this. We jump, we got it. Okay, perfect. So now let's do the mass editing so that everything looks uniform. These node guys, I'm gonna change a little because they need to become node exp, node expectations. And then the calls to CS node cannot be a thing because CS node is no longer defined. So then we open the brackets, and then we continue here. 1, 2, 1, 1, bracket, so curly braces. That's it. Yay! Okay, I think that's all we want. And then at the end, we want to verify that the root of the red black tree is null. Red black tree dot root is equal to not a null heap pointer, but a null. Perfect. Okay, we did this. Let me now read the chat now that we've finished this. By passing in this, yes. And this is will be used to fix size allocations, offsets for dynamic size allocations. Yeah. No, yeah. Like I understand what you're saying by the. I mean, fixed size makes a lot of sense, right? Fixed size indices would definitely would be like way better. In the case of dynamic, there doesn't really seem to be, there is no trade-off between the pointers and the offsets because either of them it just works. Ensures alignment is handled for you by the compiler. Yeah, I agree. If you're working with fixed size, right? Otherwise, then we need to, with dynamic, it needs to be a little different. Kiddies and ships, wishing you good streams. Oh, thank you very much. And yeah, so let's try and have this last test over here, which, oh, this is the test from hell. This is that one test that we had. That there was like an error in a code, and this test showed us that there was an error. Not the greatest of times, but we needed that little snap back into reality. So what are we gonna do? We're gonna grab this thing, then we're gonna, do something like this. Please tell me this is possible because I've been doing that and I am not sure if it's possible to do it. to initialize a struct like that just by putting these empty braces. Anyways, so when we perform an insertion into the red black tree, we wanted to pass the red black tree pointer rather than the whole thing. And for each of these guys, these inserts, right? Insert, insert, insert. Insert, there's another one here, and then remove. We need to pass in the pointer to the red black tree node fields. Perfect. And so now what we do is we beautify them again. I'm very sorry. I know. But the code needs to be beautiful. We insert here, right? Then we do the same thing here where we need to, new line, braces, and the same thing here. New line, put that there. New line, enter. And for some reason this is in a different line. So now we need to clump them together. Perfect. Then here, brother. Okay, new line. Put them all to the side. New line, and this guy. Perfect. So now we continue. So equals vector, and then we pass in the vector. This thing here, and that's it. Okay, perfect. That was short compared to the other ones. These nodes are no longer nodes. They should be node expectations. These red black tree things, they should have already been pointers. Not sure why. Oh, sorry. Need to do this. Perfect. Pass in the pointer. And finally, with CS node, we should not have CS node. Instead, we should just have the thing itself. Perfect. So we delete this and then we put that. We'll put in the key and then space. And that should be more than enough. Use of undeclared identifier assert. What? Maybe I'm missing some parentheses or something. Here, open parentheses. Oh, yeah, dude, why did I do that? Yeah. So we need to do this, and then we need to put a parentheses on there. Perfect! Yay! Okay, I think we finished. Oh my god, let's go. We can eliminate all of this. Then we do the test from health, and then we printf success. So for success, we need to include the stdio.h. Oh, let's go! finally. The left operand is a lot. Brother, what are you talking about? It's a garbage value? What? Calling test insertion in 397, 154, calling arbitrary insert. Okay, I see what it's saying. So that is a good observation. We should have a red black tree thing here that arbitrary methods, something like, create red black tree, that allows you to create a red black tree. gt start arbitrary. Sorry, no. Okay, create arbitrary should just return the same. So here and now in memory header, over here up, we just need to do, whenever we call init, we just need to do arbitrary is equal to create arbitrary. Perfect. Yay. And so here in the test, every single instance of this, needs to just be replaced by this being equal to create red black tree. Perfect. Yay. Um, let me read the chat now. So you get streams. Well, you'll see what I mean properly when you take a look at my code. Even if it's currently broken, it gets across what I'm trying to do reasonably well. Wait, so for fixed size, it makes sense, right? For fixed size, I agree the indices would be like the best decision you could make. For dynamic though, I don't really see it. You could use just either of them, right? Because you can still check bounds even if it's a pointer. And the same with offsets. Bottom Pavok, yeah, it's a test from hell. It's like because we were working with the red black tree and there was a bug in the red black tree. And the test that showed us that there was a bug was test from hell. So we didn't have this before. When we discovered that bug, we spent like a bunch of time trying to discover where the bug was, and then realized that like this was the thing that triggered it. And so we created a test called test from hell that just implements those, that time of suffering that we spent trying to debug that thing. So yeah. Is C the only language you're able to code in? I mean, comfortable. Well, I also use C++. Nah, C++ is like the language that I use the most. Yes. I can code in other things. I can code in Python, not an extreme expert, but can defend myself, and TypeScript. It's kind of limited, but I don't really care about that. I think, having C++ already is pretty good. But yeah, Penguin Operator is back. C++ is cursed. Brother, do not say that about C++. Do not say that about C++. Arbitranis. So Zig rules. Yeah, I've seen that many people like Zig. I don't know Zig. I want to also learn Rust. So eventually we're gonna have a stream where we learn Rust. That's gonna be fun. But yeah. Boom. I want to give this girl a green card. It gives me purpose. I otherwise don't have. Okay, so I think the test is fine. I think everything is good to go. All right, let's test it out. In the make file, okay, we already implemented that. So let's, okay, prepare for it to fail because I do not trust this extension. This extension for C and VS Code doesn't show me the errors. So it's very, very likely that the compilation is just not gonna work. There you go. I told you. Brother. Undefined symbols for this architecture. Oh, of course, we forgot to actually implement the creation of a red black tree. There we go. So then we're gonna do arbitrary t, create arbitrary, and that's just gonna return, a little guy, and that little guy just has a null root, right? Hello. Arbitrary t arbitrary is equal to this thing. Do I have to do this? And then return red black tree? Oh my god, the extension is so slow! Bro, extension, please, please. Okay. Oh wait, I think it's just that I could have just done this. Arbitrary t, and then pass in the null root. Let's wait for the extension to catch up. Mr. Extension, please. 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 Okay, there you go. Let me read the chat. So, ooh, okay. There's a lot of, whoa. Learn Golang. Oh yeah, Go is another one I can do. Yeah, Go is another one I can do. I can also code in Golang. I hope there will be a way in the future to code with C++ and Unity. Currently, it only supports C#. Yeah. Personally, I started with JavaScript and VB. I imagine Visual Basic. Back in college, yes, I know VB is effectively dead. eventually gravitated to C after the course and never looked back. After the course? What do you mean after the course? After some course you took in class? Sir Othman, welcome back. Download Clang the extension storage should be better. Yes, yes, yes. So I try to use the CLangD extension. It's just that sometimes it like fails. Sometimes it like crashes. For some reason, right? But I think we should give it a try. We should give it a try. For that purpose, let me disable the entire set of extensions and let's just restart. Perfect. And now because I've downloaded before and I like it more actually. I like it more because it also gives you it gives you extra information about stuff. And not only that, it behaves way better, at least for C++, it behaves way better with templates. Like the moment you introduce a template with the C++ extension from Microsoft, it like bogs out. If you use the CLangD or the ClangD, not sure how to pronounce it, it's pretty good with the templates. That's the thing. So let's see. Okay, now it's just giving me false errors. Yeah. Yeah, these things just don't. These aren't a thing. These are inexistent. Okay. Guys, we're gonna open Firefox. Are we back? I think we're back. I think we're back. Okay. Remember, when you see me open in Firefox, prepare for the stream to lag. Move to Unreal Engine. I also dabble in Lua. I see. Well, imagine Rust, the C++ that decided to throw language ergonomics out of the window to provide mathematically provable memory safety and compensate for that with tooling that just works. Also, Rust is so much faster. Yeah. Instead, Bethesda maybe. Dominic Vonk, hello. Which extension are you using? So I'm using the C++, C++ official Microsoft extension. I thought about that and also had it installed, but I'm way more comfortable with Unity. I mean, I don't hate C#, but performance-wise, I don't like it. You need a compile commands JSON file. For CLangD? Oh, I imagine. Let's. Sometimes client hates the world. Yeah, you can download a program called Bear from Brew. Yeah, I've heard of Bear. Yeah, college was my intro to various IT stuff. It was a general course way back. I see. Redefend, IDE extensions are rarely accurate. Just use the compiler, bro. Hi. Hello, welcome back, Redefend. Hi, Itachi, good morning. CloudD is very accurate. You're missing compile commands file. Yeah, sorry, Sir Offman, I just hadn't read the chat. Did you do the performance benchmark? Not yet. We are making some changes to accommodate for our performance benchmark. But yeah, okay. So we need the compile commands file apparently. And so how do we do this? So you guys are telling me, would Bear be able to detect the make file? Because like we have these flags, and these flags are the only thing that tells it what to include. Other than that, there's nothing else. So if you guys know, let me know. In the meantime, I'm going to, how to make clang detect include folders in makefile. C. There you go. Include files in CLangD. Let's go. Well, the results, Melodev, what key binding do you use for changing workspace, virtual displays in Mac? I don't use the native like Mac thing. I use this program called Aerospace. It's a very cool program. Aerospace, you should install it. And then what I do is I assign it to be the Alt key, so Option in a Mac. and then you just press in a number, and then you can change the workspaces, right? So yeah. Anyways, oh, this is for CMake. Wait, so do I just install bear and then it will work? Bear install and then run bear make. Okay, perfect. So I'm going to get the free sounds. Let's do that. So brew install bear, I imagine, would be the command. See? Oh, by the way, are you familiar with fill C? Love it myself, just haven't properly set my make file up to switch between it and GCC yet, so I'm currently sticking to just fill C builds. I'm not familiar. Is fill C the sort of memory safety checker for C? Because I remember they released something like that. Somebody created a project where they were like, oh, let's bring Rust into C in a way, right? Make sure you do make clean before you run bear make. Brother, oh no, okay. Oh no, good luck with brew. That thing sucks. Okay, hopefully it doesn't today. We'll see what happens. We'll wait. Oh, it seems like it worked. That's great. So now run make clean, right? So you just deleted everything inside of build. And if I run bear make, right? That's the command that you guys told me. Memory safety, yeah, basically for his answer to Rust for C. Yeah. It's real memory safety, unlike Rust. Okay, so let me see. The command was bear make, right? I think. Let me try and see. Yeah, Seraph man. Say clean before you run bear make. Okay, I made make clean bear make. Let's see. Oh, bear driver. Are we sure we installed the correct thing? So is it bear? Is it bear driver? What am I supposed to use? I'm a little confused right now. Bear dash dash make. Yeah, it's different on Mac. Oh, dude, that's so bad. Need to go. Nos vemos. Bye, Abitrains. Bear dash dash make. So if I do dash dash make, will it work? Oh yeah, it did. Great. Awesome. So let's see. Did it create a compile command something? Well, oh yeah. It's over here, right? Is this the correct place for it to live? Should it be under the .vs code file instead? Not completely sure. But let's see, now that we have that, maybe let me try to, ooh, shoot. Okay. Let me try to reload the window. Let me see. So we make, that said, for software that needs to be secure, that runtime cost is probably not even a concern. Yeah. Did you build all? Yes, I built all. Just one target. No, it shouldn't. Also, make sure to ignore the compile commands. Okay. And so it should live here instead of the .vs code folder. Perfect. So compile commands.json just doesn't live here. Great. Perfect. Let's see. Are the errors still there? Oh, the errors are still there. So what do we do in order to set this up? Like I made all of the tests, which are the only thing we have for now. Mainlive.h. Okay. Is there an include path for clienting extension? Yes. Oh, okay, let's see. Let me read this. Um, Also make sure to git ignore the compile commands, yeah. Sure. Mm.h might be missing from the make file. Let's see. So in the make file, well, we're including SLC, right? So it shouldn't be missing. And nor should include, because it's also being included. Or at least memlib might be missing. Add /SLC to includes. Yeah, we did it. To C path, I mean. Oh, then it could be built on JVM. Whoa. Okay, also, it doesn't look like your make file has an old phony. Oh yeah, I just have a test one, because, you know, like, I just have the test one, and the make file just does, right? It does the first one it finds. It should be test. And indeed, it did exactly that, right? It ran all of the three. Yeah, so I'm not sure what it could be, because the arguments here, sure, like directory output. Memlib.h is inside of SSC, so we should be able to see it. It is being included everywhere. Um, So all the other files started working. Well, I imagine that if I go to, it's just that the extension is low, right? Like now that we go here, it's gonna say like, oh yeah, I don't know, that doesn't exist. And if I open this, then it's gonna load, and then it's gonna tell me they don't exist. So yeah, it's the usual way. Yeah, okay, I'll try to read this. I still work with the VS Code extension. Let's see, maybe use this. Create a file called clunky in the top source level. So one thing we can do is that, but it would be better if we could just do bare. Yeah, cool. Clunky uses compile commands using database file which contains flags, such as include directories for each file in the project, but this file is auto-generated, so modification. You gotta CMake to add any custom blah, 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 blah. Bare make to generated, yes, of course. Maybe the build folder. It sometimes can't find it. So what would you suggest? Oh, okay. Move. Okay, maybe move the compile commands JSON file around and see if Clang finds it. Okay, so how? Yeah, sure, we can put it in the build. And let's try and put it there. Move, not into tests, but into build. Move. Okay. Maybe we can reload a window. Sorry about that. The moment I reload or do something with VS Code, it like crashes. Hello, coding Bara. Read the build folder. Oh, Dominic Vonk is suggesting do the clunky file and add clunky.arguments and then compile commands there equals build. VS Code also has an option refresh extensions. I just usually resave a file for clunky to retry. Okay. So one question. So compile commands, should it really be in build? If I put it outside, I think we can just do what Dominic is suggesting and then just have it there. Either lag is from stream or my page needs to refresh. I'm gonna try that later. No, don't worry. It's like if I refresh VS Code, then it all goes, it all goes down. Yeah. So it works. I would say yes. Oh wait, does it work? Oh, it works. Okay, so it expected it to be in build for some obscure reason. Great. Thank you very much, Serafman, and same for Dominic Vonk. Guys are great. Thank you. Yoo-hoo. Okay, perfect. All right. So, great. Now, I have a question. When I run bear make, right, bear make, I should specify that the compile commands goes into the build directory. How do I specify to bear that it should put compile command inside of build? Or do I just, I just generate it and then move it manually every time? Which would be maybe a little bit annoying. Not completely sure though. Let me reset. Okay, given that, let's go into a build console and let's just run the tests because it seems like they didn't fail, right? So arbitrary test. Ooh, we have problems. Okay. No clue. Okay, that's completely fine. Yeah, as we expected, unfortunately, there are gonna be mistakes. Oh, within our translation of stuff. Bear, I wouldn't say it's like the proper way. Compile command feels like it was designed for CMake. I see, yeah, but like now we have to, we have to add CMake and everything, which I don't really want. Mm. Alright, let me see what the error is now. Okay, I guess we can just run the debugger on it and take a little look, a little peek into it. So rather than emit test random, I want to run I want to run arbitrary test. Not the one in bins. I want the one inside of build/tests/arbitrary test. Perfect. Okay. Let's just run this and see where the error occurred. Oh. Oh, I still need the C and C++ extension for debugging. Oh no. Well, enable. Now if I enable it, yeah, disable IntelliSense so that they don't have a conflict. Read the workspace for this settings to take effect. Reload. Are we back? Are we back? Yes, yes. Okay, perfect. We're back. I think everything's fine, right? I don't see them highlighted. Okay, yes, perfect. Everything's fine. Yay! So now let's run the debugger and see where the assertion takes place. Because if we run it, then we should be able to see what happens. Let's wait. Okay, it's asking for my password, which is 1234. And let's wait. Okay. It seems like there's a problem here. Then we continue. We get an assertion error. And I want to take a look at what the problem is. So we have vectory, right? Res, right? Then we... Oh, shoot, of course. Because we need to, res is not the beginning of the red black tree. The beginning of the red black tree is the red black tree's root, not res. Okay. That makes a lot of sense. Hello. Oh, arbitrary dot root. There you go. Perfect. I think that's more than enough. And so now we need to correct that also over here because we put in the wrong thing. Arbitrary dot root. Damn, this extension seems to be a little more nice. I had tried it before, but for some reason it would, sometimes just complain, not work at all. Bear make. See what happens. Okay, did bear put the compile commands where it belongs? Okay, no, it didn't. How to specify the folder in which compile commands should be saved to embark. Yes, let's see. You see, oh my god, dude, brother. Output. Oh, okay, that's fine. Sure. So let's run that make and dash o slash. Then I specify the build folder, right? Report creation, serialization error. This thing is a directory. Oh, am I supposed to say compile commands.json? Oh, seems like it. Yep, that seems to work. Okay. Let's do, so build.temp, I don't need this. I also don't need the compile commands over here. Great. Okay, I think it works. Yay. So now what we're gonna do is run it again. Run it again because previously it was because of a mistake. So let's reset this. Reset. Go to 1, 2. Another assertion failed. Oh no. Dude, oh, come on. Please, 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 please. We'll see. Test the left rotation, and then we fail over here. So we are indeed passing the root, which is the correct thing. Oh, the root is just null. What? Oh, I shouldn't be passing the root. Okay, I shouldn't have made a modification that I didn't know was correct. Okay. So I think that indeed what we should do is res. Yeah, okay, so it was correct before. Yeah, I'm just stupid. Res, there you go. Oh wow. Did you see that? It's like arbitrary.root, and then I change this, and then it immediately adopts it. Damn, that's fast. Let's go. So if we make there again, perfect, and then we run it, we see the assertion failure. And now we want to take a look at what is it that's going on. Right? Why are we getting this error? So, whoa. A little sleepy today, not sure why. But the red tree to vector, it stores the result in the vector tree. So let's see what vectory has. Vectory has we cannot really know. Okay, I guess so. And we cannot do macros here, right? Impossible to inspect the container of that, right? Vectory, maybe we can? I don't think so, but still, let's try that. Vectory I, of course, we pass in a pointer, and then we pass in the data, then the arbitrary node. Is this a valid thing? No, of course. Okay, that's fine. So what can we do? Right. What can we do? Let's see. Because vectory stores the information. Because it has left, and then PC is exactly the same, basically. So we're not really able to know what the problem is, because we cannot even print whatever's happening. Which is a huge disadvantage. I think if we do something like this, data, it's equal to this, we are able to know the value because it's going to be stored in a variable, and then that way we're going to have it available. Called object, I mean, I don't know, data node, new data node. What? Oh, semicolon, of course. Let's reset this, It's build again. Perfect. Yeah. Notice the semicolon. Sorry about that. Let's run it. We have the same assertion failure, but now the debugger is going to be able to tell us what the thing is. Is it not going to be optimized out? I compile it with debugging symbols, so hopefully not. Yeah, data node is still there. Okay, so data is 90. Interesting. So it's 90 instead of 10. Oh no. Oh no. Okay, that's really bad. Oh wait, no, but what I is it? Is it I0? Oh shoot. Oh no. It should not be this. Oh no, that means something like while we made the modifications, something in the red black tree just like was implemented incorrectly. Oh, that's so bad. Because now we need to now we need to redo everything in the red black tree thing. Ah, okay. Arbitrary to vector. Yeah, this is what you expect. And that's indeed what happens. Yeah, because 5 is the root. Then 10 is on the right. So when you rotate to the left, you expect 10 to become the new root. That's exactly what should have happened. Oh, but we're rotating 10 for absolutely no reason. It should be 5. Oh my god. Let's rotate 5. Why are we rotating 10? Okay, I feel that explains a lot of things. Yeah, because 10 was the one that we needed to rotate here. Oh, okay. That saves us. Yay. Okay, we get to breathe another day. It ran. Now let's reset and let's run. No, no. Okay, let's let's run and see what the problem is. So, is the problem still the 90? Hopefully not. I usually have such bugs when I slept less than 4 hours. Yeah, I slept less than 4 hours yesterday, so that kind of checks out. Let's take a look. So we have data node still in I equals 0, and we're rotating 5. So like the rotation is now completely different. And 90 is still the first. So there's something weird. There's something fishy going on. Because even though we changed the, origin of the rotation, it just didn't care. And it just gave me the exact same result. Well, we I don't even know what to say. So how come the change of the root didn't are we merging the correct things? Like are we, are the trees the same? Because we have here we have 5, right, 2, 10, 8, 12, 6, 9. Yeah. Then we link 5 with 2, 5 with 10, 10 with 8, 10 with 12, 8 with 6, 8 with 9. Yeah. True, false, true, false, true, false. Yeah. The response is going to be left rotate 5, which indeed it's what happens. Okay, I want to know what is the thing that gets returned here. So rest node, it's going to be just equal to the container of, and then container of this thing for rest inside of this data thing with arbitrary node. And then let's try it out. Hopefully compiler doesn't optimize it away. I don't think it does. Reset. And let's run once that other thing is done. Yay. Okay. Buran Pavuk, #no front. I should have such for. Oh yeah. Okay, we have the same mistake, but now let's see it in the debugger so that we can tell what's going on. So, boom, 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 me. Okay, we test the left rotation and notice that here we have a mistake. So what is it? Now, what's the value of rest node? Rest node is 10. So it is doing the right thing, right? Yeah, it is doing the right thing. So the problem is going to be this function that converts things to a vector. Because rest node, which is the root, is 10 indeed. Which means that over here, when we do the container of whatever, we should be seeing the first element of the vectory thing, v10. That doesn't happen though. So let's investigate. Let's investigate what has happened. What has happened? A man has been thrown into the river in Lego City. Hey. Okay. So we have this result is equal to node. This is totally fine now. We're just copying the data over. Right? Am I missing something? No, right? Okay, I guess I'll stop the debugger right when we're about to do this, and then just inspect the variables as we go. Test the left rotation, whatever. So here we enter the first one. And the node that should be given to us should be 10. Oh shoot, we cannot even inspect. This is so annoying. Okay, let me see. So what is 10? Inside of the test left rotation, here, 10 has address. This guy. Oh, did it just not tell me? Okay, well, that's unfortunate. Because when we do this, right, we get the response, and then that gets stored into the... Yeah, right, it should be totally fine. Should be totally fine. So I guess we're gonna have to create a variable here so that the... Oh my god. Node is equal to the container of whatever this is, right? Container of node under the data thing. Oh, we cannot even inspect that. Oh my god. Do you guys see any mistakes? Like, what is, what is the problem? Anyways, what is the problem? There's nothing happening, right? It's arbitrary to the vector, right? What we do is we grab whatever that node is, we copy the data over to result, and then we're happy ever after. No? I think so. And we should be fine. We should be fine. Okay, so, like, is it just that doing this, like, it shouldn't change at all, but, like, what is the problem? Huh? I mean, changing this to pointer, but, like, they are equivalent. They are equivalent, so I'm not sure why this would change things. It is strange. Result is not a pointer. What do you mean? So result is an array, right? It's supposed to be an array because you're converting the red-black tree to a vector through the pre-order traversal. Yeah, it was like this, right? It's supposed to be an array. This is the way it's supposed to be. But arrays are just pointers, right? So this should also work. Let me just try out and see if changing it to a pointer changes things. Yeah, let's see. Yeah, no, it's the exact same problem. The exact same problem. Because it decays to a pointer, but I'm not sure if it's the correct sentence. Yeah, like if we just make it as an array, right, it should be equivalent also to doing this. And then here, we just add one position to it, and then we skip an element. So it's like, okay, coding Bara, any book you would recommend or series of them to learn C from syntax to elite ball knowledge? I'm not sure. I haven't read any books related to C. I've honestly just coded on it and realized how to do things on the go. So yeah, I can help you with this. I wasn't following. Oh, don't worry. Yeah, so here if we run this, like, it, like, now we try to run it. Yeah, it just fails in the same spot. Okay, let's try and see what it is that's going on. So if we run this, oh, is this Beej? From Beej's Guide to Networking? Wait, is that a... Give me a second. Well, we'll try to debug this. I want to take a look at the link too, because, Beej is the goat. I'm not sure if... I think that's how you pronounce his name. Let me know if it's not. So res node is supposed to be, data is 100. So that's the first thing that you pass to this thing. And its left is, remember this, fee 38 and fed b8. So let's enter here. And then this one, right, this node is fee 38 fed b8. So it is getting fed the correct thing, right? It is being fed the correct thing. So it's like, result 0 equaling the node. Result 0 should have fee 38 fed b8, right? Let's see if this gets overridden. Oh, I think I know what's happening. Oh, okay. Let me... Yeah. I think I know what's happening. Okay. So I'll explain in a second. So this should not get overridden, and either way, yeah, this is just a different call. Yes, so I guess I should have disabled the breakpoint. So what's happening is this. I think it's like a little subtle what's going on. So what happens is this. When you give me the node, right, I want to copy sort of its data into result. But notice that, like, this is just the node T. So this is just the red-black tree node. We want to, inside of the test, be able to extract sort of the information that thing is storing, right? So what actual data was that red-black tree storing? And the way we do that is through the container of macro by, from that little pointer, grabbing the container structure and then, calculating the offsets and everything to obtain the actual data. Now, when we copy this thing, right, Despite these two having the same information, they are now different pointers. So this one is being contained in a data struct. So when we do container of and we go out, we're able to get the data, but this one is not. And so when we run the container of macro, it goes out, it accesses the offsets it needs to access, and then it just gives us a bogus value because that just could be anything in memory. And so that's the reason why we're having this, right? Because we cannot copy just the information. We need to copy the pointer itself. So this should be an array of pointers. And then what we do is we say result at 0 is equal to this, right? And now we modify the signature so that it accommodates for that, right? There you go. This should be an array of pointers, and that solves the issue. And the only thing we need to do is simply accommodate for things here, sort of our, So this should be an array of things. I don't think we need rest node anymore. What we do need is, let's see, we left rotate, we do rest, yes, vector tree, and then vector tree should instead be an array of node pointers. There you go. And so now when we run, the container of vector tree I without passing an address, we should be able to get the right thing, right? So that's what was happening. Foot long icicle, welcome. But yeah, that beach. Yo, let's go. Been chilling. Whoa. Do you like assembly? Never really coded in assembly per se. I mean, I guess I've done it, but like I haven't done like a serious project that it's like, oh, let's write something in assembly. Zero Nisil, welcome back. So I don't know. I feel like assembly is it's assembly, It's like little guy. It's great, It's like yeah. Anyways. We need to perform the same modifications here when we do this. So we need to do that. And then that solves basically all of our issues. Perfect. And now we need to do it in the red black tree equals, yeah, there you go. So this guy becomes a node pointer. And then when we do actual data, we need to simply access not that, but instead this. Right. So MD color should be this. There you go. Perfect. I think we're fine. We're good to go. All right. That should work. If it doesn't, I don't know what to tell you. All right, Beme. In the meantime, reading it is fine, but writing something serious in it is going to turn into FFmpeg. FFmpeg as an amount of mess. Flexing with the golden guy. Kappa guy. Assembly is nice. It doesn't have any features I hate. Yo, let's go. Food long icicle is being greeted by penguin operator. Rudifend, it has no features, so that's easy. True. It's vacuously true. All right, let's try and run this. Oh my god. Dude, come on, please, let us out. Let us out of this misery. So line 134. May that be an error with, let's see. So we test the right rotation, right? And then this looks exactly the same like what we have here now. Container of vectory data arbitrary node. Then we access the data, then it is equal to the expected. Yeah. Wait, that's pretty good. Okay. So what is the problem now? Is it that we, copied the wrong thing? Is the tree what it's supposed to be? So right rotation, right? When we do right rotation, we're doing vectory, then arbitrary to vec. Yes. Expected is 5, 2, 10, 8, 6, 9, 12. Yes. Now when we continue here, we assert that the sizes are the same. Yes. Are we rotating on 10? Yes, we are. So what is it now? Oh, the tree is completely different. Brother, the tree was completely different. We assumed that it was the same as the last one, but no, it's completely different. Okay, that makes sense. So let's try and fix our mistakes by just adding this and then adding a pointer to the arbitrary node. And then finally here, sorry, we do a very similar thing. Simply transition and we do that. And then do dot arbitrary node. And that should fix it. Perfect. Okay, now it's gonna work, I guarantee. I cannot guarantee you anything, but you know. The Macabre, welcome, good morning. Did you fix the fuzzer, by the way? I'd assume so. Yes. We fixed the fuzzer, we did everything, and in fact, we're now writing our red black tree to be an intrusive data structure. So rather than whatever it was before. So yeah. Now we're trying to port the tests. Segmentation fault. Oh my god! Porting these tests is so bad. Ah! Anyways, where does the segmentation fault occur? So let's try and go here and let's run it again. If it is in our main code, I'm gonna be really sad. Because let's see, arbitrary to vector. Yeah, that's fine. Shoot. Oh no. It's in our main code. Okay. I should not have changed the red black tree to an intrusive data structure. It's okay. So we're running color on a null. Why are we running the color of a null? Wait. What am I doing? Yeah, of course we can run that. Of course that's a thing. Right? We had a color function somewhere around here. I'm pretty sure. If for some reason we got rid of it, I think. Okay, so if we go here, actually, and then you look at color, right? I think ND colors are that remains, right? But it shouldn't be. Yeah, because there's something very important that we need to remember, and it's the fact that obtaining the color of a nil node is black, right? So return this. So if node is equal to null, right, oh well, it's different from null, then we're going to return the actual value. Otherwise, we need to return black, because the nil nodes are black. So that's the reason why that was failing. That's a little unfortunate. Yeah, so I do want to include some assertions here. I want to assert that node is not null. Node is not null. And then I just do the same for all of them except for the color, because the color can definitely be called with a null pointer. So then we try to set the right. We try to set the parent. Try and do this. Color can stay, but setting the color now. Okay, run bear. 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 Okay, anyways. Ruby or not, Ruby or not. Yeah, I don't know what I'm doing. I'm gonna go insane. Oh my god. Assertion failed. So the tree doesn't look like this anymore. Guys, what's going on? Somebody please help. Let's see now. What adventures await for us? Let's run this. Okay. So when we run the test for insertion, right, when we try and insert, what do we get? So right, arbitrary insert, it does the red black tree, right? And it inserts 15 as a node. So when we do the insertion, it is pretty clear that the only thing here is the root, and the root is null. And so now the root should be equal to the node. But that doesn't seem to be the case. It seems like the root stayed just completely null. So let's try and see what happens. So let's run this. We have some good news nonetheless, and it's the fact that our left rotation works and our right rotation works. Now when we test insertion, right, we create all of these guys, which is perfect, awesome. And then when we try and insert, of course, the root of the red-black tree should be nil, yeah. So now we try and say, okay, that thing is null, very clear. So we enter here and we make it equal to be the node, right? And node is indeed defined. So then we skip this. And then when we try and insert fix whatever this is, what is going to happen? So we set the left to null and the right to null. That's exactly what should happen. Pay attention to this root thing. We set its color to be red. So we should see inside of node a change in the PC thing. Well, actually, no, because red is 0, so never mind. We grab the current one, which would be the parent, and that should be null. So current is null, yeah. Then we say, well, if the color of the current one is black, then return, which should be the case. Then we return. Yeah, so after this, the red-black tree's root is an actually defined pointer, and it's indeed what we want, right? So the root is there. Then after this call, we go, and then let's try and see what does arbitrary equals vector do, because it is the correct value, right? 150 and black. That's indeed the case. It's black. Oh. What? Hello? Well, what happened? Why did it become 0 all of a sudden? Did you guys see that? It's very weird. So, test insertion, create the red-black tree. We create 15, right? And then 5 and all of that and whatnot, right? Create it. Then insert, and the node that we are being passed is a pointer, right? The node ends in EDC8. EDC8. So now the root should end in that. EDC8. EDC8. Yeah. So this node, it just has no information, right? No left, no right, no parent. That's fine. Oh, sorry, yeah, that's completely fine. I don't know what I was tripping about. Actually, no, it's not fine. It's not fine. Okay, I see where the mistake is. The mistake is here, right? For some reason, we didn't account for the case where this is the first thing being inserted. So if whatever current is, if node, right, is equal to the root of the red-black tree, then we need to color it black. We need to say nd set color to be black. We need to color it black, and then we return. Perfect. That's it. All right, that should fix it. Now we run again. Think, ooh, we only have 8 minutes. So let's do this, and then let's reset. Then let's run the tests. Oh no. Okay, what's wrong now? What's happening? The red-black tree root is equal to the node that you just inserted. Just set its color to black and return. Yeah, that's exactly what should happen. Okay, let's run this. Let's wait for the assertion to fail, and let's see the code stack. What is the problem? Rotation. So we do this. Right? I want to see where we fail. The call stack says we fail on test remove, which is interesting. Like we managed to survive all the way until here, and then here we fail. Okay, So we call arbitrary remove, and then we call swap between a node, which is valid, and then its heir. It should also be fine, right? So what is the problem? If it is a left child, whatever you're swapping with. Oh, that's interesting. Yeah, because you're not going to. Okay, I see. So this is a consequence of us getting rid of the ghost node. So swap should be modified, right? So parent exchange. Right. So yeah, this is a little ugly. A little ugly. Because so we need to exchange parents, right? So that means that if I swap the root with a different node, then I need to update the root of the tree. So this is the reason why we had a ghost node in the first place. Should we just reinstate the ghost node, to be honest? Like, you know, it's like, I mean, I am so willing to do that because the ghost node provided a good abstraction. Where swapping things was just natural, right? You didn't need to check for all of these cases. So what I mentioned about the ghost node, like you guys know about the ghost node from the previous streams and etc. And it's basically a node that is useless. It's just there. But it is the node to which red black tree points to. So the child of the ghost node is going to be the root. And what happens is that since the root is always going to have a parent, it's as if things happened on a subtree. And so you don't need to check for special cases. You don't need to say, oh, if my tree is the root, then since it doesn't have a parent, then I need to do this. No, you just perform any rotation you want. And you know that the ghost node is just, a dumb guy. Like we just don't use it. Yeah, because I don't want to be checking all the time. Like, is this the root? Is this the root? Is this the root? Is this the root? So we might as well implement that, right? I think so. Although, I mean, no. Let's just add the conditionals. Let's just add the conditionals. Okay, we have 4 minutes left for the stream because I gotta go after this. So let's try and do things here. Let's try and make the red black tree tests pass, so that at least we can have some sort of peace of mind, if you will. Where is swap defined? Swap. There you go. Yeah. So here when we swap, we say, well, if this is a left child, right, there is a sort of different condition, which is if a is equal to the root of the tree. And so now to swap, you also have to give the red black tree, which is something I didn't want, but it's okay. Arbitrary and then a pointer to it. And then we need to also update the header for the red black tree. So when you call swap, there you go. We need the red black tree T and then a red black tree. Do. Perfect. So now we do here. Arbitrary. If A is equal to the root of the red black tree, then there is no parent exchange to perform. Well, there is, right? But you just set, you just don't do anything, I guess. Let me see. Yeah, no? Wait. Yeah, we don't update the parent. So the parent doesn't. Wait, what are we doing here? So if A is a left child, then I tell the parent of A that its children is different, that its child is different. And thus, we should skip this if A is equal to the root. So if it is different from the root, then we do this. I don't like the indentation, I know, but we should just put it that way. And then if the regular tree's root is different from B, then we do this. So one of the things I want to include in the to-do is to say some cryptic message like ghost node allows us to go branchless. So we'll revisit that in the future and we'll take a look at the ghost node. But okay, if the root is there, now we need to exchange parents. The parent of A, we set the parent of A, and everything after this is totally fine. Okay, I think that's fine. So now we can reset, and let's run this again. Oh shoot. Yeah, I forgot to update the call. Now you need to also pass the red black tree. Perfect. Let's reset, and let's build. Okay, no compilation errors, that's great. Then we do /tests/arbitrary test. What's going on now? Oh no. Okay, let's try and debug this one now. Yeah, all of the changes we made to make it an intrusive data structure are kind of, now we have to pay the bill on those. So let's see what it is. That rotation, everything, So it happens on remove again, but it happens on a different one or the same? I'm not sure. So when we perform this assert, it just says that the tree is completely different. Interesting. So this assertion is the one that fails for who knows what reason. Yeah, I think we'll have to revisit this tomorrow. It's already 10 a.m., so I gotta go now. But yeah, it's unfortunate. Like, I guess this is, something that happens in every migration, right? Like whenever you're trying to migrate something to something else, there's always going to be mistakes related to you rewrite. So we migrated the red black tree to an intrusive data structure to maybe improve performance, and maybe not performance, right? Because it was very performant before, but rather to make it reusable and to make it sort of more professional in a sense. Yeah, so now we have to pay for the broken plates. Let's transit to this thing, obtrusive back. I'll do it one last time. So variable, what does it say? Variable not available. Oh, what the hell? What's happening? Okay, bottom public, have a good day too. Have a good day too. And yeah, I'll try and debug this last second. Let's see, is it clear what the issue is? Maybe we fail, in I0. So now we're disagreeing on who the root of the tree should be. So the actual data says it's 13, and the assert checks that it is. Oh, sorry, this is not even the. And the assert wants it to be 170. Oh, why is it 130? 130 was removed. Yeah. Anyways, I think we'll have to check the code then. So for now, that's all we're gonna have for today, unfortunately. Also, my hair is kind of crazy. Yeah, I'll try to solve this in the evening. I'll take a look at it. I'll take a look at it in the evening, see where the error is, hopefully solve it so that you guys don't have to see me debugging all the time. And transition to the fun part, which is actually using that red black tree, checking our memory allocator, and once all of that's done, we'll be able to measure performance. So yeah, have a good day, everyone, and I'll see you tomorrow. It's same time, 7:15 a.m. PST. So yeah, sorry if this stream was a little bit boring. It was at least boring for me because we just needed to port the red black tree. But it is what it is, right? These are things we need to do. So yeah, see you guys. Bye bye.